Hey everyone, Mr. Newman here, and we're going to do a few other problems, word problems with systems of equations, but what we're going to do is these are different kinds of equations. Instead of using ax plus by equals a total, what we're going to look at is ones that look like this, y equals mx plus b. So let's get started. Bins, movers, and shakers charge a $75 setup fee plus an additional $60 per hour to move a family's possessions. Speedy Steve's charge is only $40 per hour, but their initial setup fee is $200. So first thing we want to do is we want to notice that all of these are going to look like this. Y equals a starting value plus a rate times x. And I'm going to look at bins movers first, and we're going to say y equals the starting fee, that's the setup fee, is $75 plus $60 per hour. Anytime you see a per, that usually means a rate. So $60 and then times x because it's per hour. Speedy Steve, I'm going to write down in green here, his initial setup fee is $200, so y equals 200. But he charges only $40 per hour, so it's plus the rate is 40 times x. Now, a few comments. First off, we should define our variables over here. This works a little bit differently than the other kinds of problems because y here could be Ben or Steve's y, and that just means cost. So it's kind of more generic, but the first y is Ben's cost, and the second y is Steve's cost. So we're just going to use the y equals the cost. For x, that's just the number of hours. I can get this because you see the per hour there, per hour. Whatever that is per, that will be the value that you're multiplying by the rate to determine how much that costs or how much that you have. So whatever it's per, that's usually the x value. Now, one other comment is you notice how this says y equals mx plus b, but my equations look like they're flipped. You're welcome to rearrange those if you want to write 60x plus 75 instead. Whoops. But you don't have to, okay? So you could write it like that, or 40x plus 200. I'm putting those in parentheses because you don't have to, and especially using the way we graph, the first way, writing it like that is just as good. And honestly, I think of it better when I think of the starting value plus the rate, because that's how much it's increasing by. So, without doing any math calculations, complete the following statements. If you knew that the moving company was going to be there a long time, blank would be less expensive. Well, Steve's company is less per hour. So if there's a really, really long time, his is going to be less expensive in the long run. Likewise, if you knew the moving company would not be there very long, we'd want to use Ben's company. That's because the initial cost of the starting cost is smaller. So, after how many hours would it cost the same amount? This is where we're going to use a system of equations. So we want to figure out when x is the same, when is y the same, when are the x and the y the same. So we could graph, we could use elimination, but I'm going to use substitution here. Let's put a box around 200 plus 40x, and I'm going to substitute that in for y in the other equation because it's equal to y. So we get 200 plus 40x equals 75 plus 60x. Let's move all the x's to one side, so subtract 40x from both sides. Then let's subtract 75 to start getting x by itself. Divide by 20, and we get 6.25 is x. Remember up above, I wrote down that x is the number of hours. So we have, after 6.25 hours, it would cost the same. Notice I wrote a complete sentence to answer the question, so make sure you're doing that. Another company, Tom's Trucks, has a deal where they will be moving anyone's things for a flat fee of $600. Write an equation for this. Well, remember, cost is y, and there's a flat fee. The cost is always going to be $600, so y equals $600. You can also notice that it doesn't matter what the x is, how many hours it takes them, so there's not going to be anywhere for us to plug in x to change that value. So that's another way that we can look there and go, we don't need an x. In fact, if we put an x in, it'll be wrong because it doesn't matter how many hours they spend moving, it's going to be $600 regardless. All right, After how many hours of work would it become more cost effective to use Tom's instead of Steve's company? Well, here's Steve's company, and we've got Tom's company right up there in purple, y equals 600. Let's use substitution again. We'll put 600 in for y, and we'll solve for x. So let's see here, 600 equals 200 plus 40x. That's when the cost would be the same. Another way of asking is, when would Steve's company cost $600? And that's exactly what we're solving right here. Then divide by 40, and we get x equals 10. So, in a complete sentence, after 10 hours, Tom's company would be more cost effective because Steve's would be more than $600. For the next problem, you want to read it like this. When you're printing t-shirts for a sports team, club, or fundraiser, you need to set up what's known as a printing screen. This just has to be done once. Basically, it's a master pattern for the shirts to be made from. 2 different companies' printing costs are shown in the table below. So the printing screen, that's the one-time cost. That's the starting cost. And the cost per shirt is the rate. See the word per? So I'm going to write down y equals, for the Frederick Sports Company, 49 because that's the screen fee, that's the one-time fee, plus the rate per shirt, so 7 times n. And they said write an equation for the cost to print in t-shirts using each company. So we want to put 7 because it's 7 per shirt, and in shirts, 7 times n is that cost of the shirts, and then the 49 is how much you start with. For the t-shirt heaven, the print screen, the one-time cost is $25, and it's $8.50 per shirt, so $8.50 times n. Here are our 2 equations. It's important to label. We already have n is the number of t-shirts. The question told us to do that, so we don't have to rewrite it. But it's important to write down y is the cost. All right, if we want to print 100 shirts, which company would cost less? Well, if 100 is the shirts, then let's plug in 100 for n and see which company is smaller when we plug it in for both companies. Let's see, the first one's going to be 749, and the second one will be 875. So the 875 costs less, the Frederick Sports Company. Let's write that out in a sentence. Frederick's Sports Company would cost less. All right, for this next part, 2 different clubs brought the same number of t-shirts, but they used different companies. As it turns out, the bill is exactly the same for them each. So if the number of t-shirts was the same and the cost was the same, they're asking us to look for this solution to the system of equations. When are the number of t-shirts and the cost the same? Well, let's solve it. And I'm going to use substitution again. I'm going to plug in 25 plus 8.5 n for y. So that looks just like setting the 2 y's equal to each other. And let's solve for it. Let's subtract 7n from both sides, and then subtract 25 from both sides. Then we divide by 1.5, and we get n equals 16. That means they must have bought 16 t-shirts. How much was the bill for each club? Well, the bill was the same, so we only have to plug it into one of them. It doesn't matter which one. Let's plug in n into the red one here. And when you do that, you get 49 plus 112, which is 161. So the bill was $161. T-Shirt Heaven charged a group $458.50 for their t-shirt order, but they forgot how many shirts they needed to make. Using math to justify your answer, how many shirts should they make? Well, remember that the $458.50, that is y. That's our y value because cost is y. So let's just plug that in for y and figure out what is n. Well, subtract 25 from both sides, then divide by 850, and we get n equals 51. That means the order was for 51 shirts. They should make 51 shirts. Thank you very much for watching.